Hello there, I'm Sajjad Rabi and welcome to part 2 of Houdini Flip Morphing tutorial. If you didn't check the first part of this tutorial, you can find its link at the description below. In the first part, I was talking about suction force and of course target force. But in this video, I'm going to talk about the third method of flip morphing simulation. I will explain how flip simulation is working exactly and why we need to play with flip particles directly rather than playing with the flip volume velocity. We are going to create some custom forces to control the particles of the flip simulation, and we will work on very simple project to show you how you can art direct your flip simulation. And of course, all of these techniques are not just useful for visual effects but for motion graphic as well. At the end of the tutorial, I will build very simple lighting and shading setup with Mantra rendering engine. So let's jump into the Houdini and begin it. Before to jump into the project, let me explain why I want to create custom force to control the flip particles directly instead of working with the flip volume velocity. Before doing that, let me show you how flip simulation is working. Here we have some particles and the background grid is the volume or the flip volume. At the first stage, we have some particles and they have some initial velocity vectors. In the next stage, we are projecting the interpolation of those velocity vectors into the volume. So the volume velocity is these gray arrows. And in the next stage, we are solving the flip simulation, for example, by using the Navier-Stokes equation, and we will have the new velocity vectors. You can see them as a dark gray arrows. And in the next step, we are transferring the new velocity, the new volume velocity into the particles. So the particles will have the new velocity vector. And finally, we are pushing those particles toward the new velocity vector and we will have something like that. So, as you see in flip simulation, we are dealing with both particle simulation and volume simulation. And that's why if you check the flip solver, you have two different input. One is for particle velocity and another one is for volume velocity. Based on this operation, when you are dealing with volume velocity, controlling the particles separately is pretty hard. But if you are going to use the particles velocity directly, you can control the motion of each particles individually. For example, ask this particle to go right, or this one going down, or this one going up, for example. Here is another example. In the left side, we have the flip particles, and in the right side, we have the target VDB. And for example, suppose we want to play with target force. When using the target force, the particles are going toward the target object and we will have something like that. And suppose I want to cut some portion of the target VDB and let these particles to fall down, something like what I have here at this frame. But if you are going to work with target force, you will have something like that, because by cutting the target VDB, we have some particles here, the remaining particles, but now we will have the new version of the target object, and the volume velocity are pushing these particles toward the new target object, and all of them are going to be inside the new shape of the target VDB. We cannot make a group for these particles and ask them to fall down instead of going toward the target object. But by using the particle velocity directly, we can make a group of those particles and apply different force to only those particles, not the particles which are inside the target VDB. And we could have something like that. We can, for example, apply gravity force to those particles and exclude them from the target force. And that's the reason why I want to play with the particle velocity for this project, not the volume velocity. So let's jump into the project and start to do our setup. Same as usual, I'm going to drop down a sphere and use Flip Floyd from object. And also we need to have the ground plane as a collision object. Let's push it down a little bit, -2. And it's good to have more flip particles. So in the Flip Floyd object, I'm going to decrease particle separation to something like that, 0.025. And here is the flip simulation. And let me organize these nodes. I don't want fluid interior for this project. Now I want to create a target force, but to control the particle velocity, not volume velocity. So we need to have target object. I'm going to create geometry network. Let's call it target, make it red. And I want to use trace sub to convert Houdini logo to the curves. You should have Houdini logo in your project here. And maybe increase threshold to 0.75. Okay. Using poly extrude it a little bit and also turn on output back. Here is the target object. Let me scale it up a little bit by using transform sub. Uniform scale to 3, push it up by 1. That's good. Now we need to convert it to the VDB because we need to have VDB version of the target object for creating our custom target force. So VDB from polygons. To have more details, I would like to decrease voxel size to something like 0.0, maybe 15, and turn on fill interior. In the next step, I want to create volume gradient. If I want to tell you what volume gradient is doing exactly, I would say it's something like the normals for polygons. Suppose this sphere or this circle is the VDB. The volume gradient is some kind of the vectors which are pointing toward the surface of the VDB. And we need to have these informations to build our custom target or suction force. So for doing that, we can use VDB analysis node here. And let's change the name to, for example, grad. And here we have the gradient vector, and as you see, the type is vector. But we also need to have the surface as well, so I'm going to use the merge sub and keep the surface which we have here. Now we should have both of them, surface and gradient. And using a null target VDB. Okay, go back to the Autodob network. I need to drop down pop-up. Let's call it target force. And of course, connect it to the particle velocity input of the flip solver. In the inputs, I need to read the target VDB, so set it to the sub, for example, and in the target VDB. inside it, you can read the surface VDB and volume gradient VDB by using volume sample and volume sample vector for gradient. Connect the sample pose to the position of the particles, same for this one, and we want to read the surface and volume gradient from the target object, and the target VDB is set to input 2, so we need to connect file name to input 2, and same here. Here we are going to read surface, and here grade. Of course, you can produce volume gradient directly in the web network as well by using volume gradient, but I'm more happy to do this outside of the dynamic simulation by using this node. I think, maybe I'm wrong, but I think it's a little faster. Okay, that's good. As I said, the volume gradient is some kind of the vector toward the surface of the VDB. So let's see what's going to be happen if I connect the volume gradient to the velocity of the particles directly. Okay, it's working, something is happening, but the particles are going away from the target object. So the direction of volume gradient is not correct. I'm going to use negate, or you can multiply it by -1. Okay, now it's working. But it's not correct to connect the volume gradient directly to the velocity, because we might have some different forces in our simulation, and we need to have the incoming velocity from those forces as well. So we need to use the incoming velocity here and add it to our new velocity. Okay, now we have two different motion. One is for our target force and another one is for gravity, as you see here. And now it's time to use the surface. Volume sampling is giving us the distance of the sampling position inside the VDB object. For example, if the sampling position is inside the VDB or volume, the number is smaller than 0. And if the number is positive, it means that the sampling position is outside of the VDB. And 0 means it's on the surface of the VDB. So if you want to check it or visualize it in the Houdini, you can use a fit range, and I want to have one once the point is inside the VDB. So I need to set the minimum to 1 and the maximum to 0. Drop down color mix, red for primary color and green for secondary color. Connect output to bias and connect it to the CD, but we need to disable the blue color in the viewport. So in the flip fluid object, in the guides, particles, you need to set this parameter to none. Okay, it's not working because you need to increase the exterior band voxels. Let's try 100. Okay, I think it's working now. In the fit range, decrease source max to 0.5. Okay, now the green color means the points are inside the VDB, and the red color means these are outside the VDB. The reason why I want to use the volume sampler is I just want to use target force for any of the particles which are close to the VDB object, not entire points in my flip simulation, even for the points which are far away from the target object. So for doing that, I need just to multiply the output of the feed to the output of the volume gradient. So multiply node, and that's it. Now, as you see, the red points are not affecting by the target force, but by gravity force. And the green particles are staying inside the target object. Now let's see how we can enable or disable the target force on certain frame, for example. And here at the beginning, we don't have any target force, but after certain frames, the target force is attracting the flip particles. We can do that simply by using a custom attribute for particles. Let's create a bind node here and read mask attribute and multiply it by the output of the volume gradient. So if the mask attribute is 1, we are using the volume gradient, and if it's 0, we are not using it. To test it, I'm going to create a pop wrangle here. First, let's say mask is equal to 0. So in this case, we shouldn't have any target force, which is correct. And if it's 1, we should have target force. Or maybe even we can say if the position of the points is more than 0, the target force is 1. Let me disable gravity. Okay, it's working. Okay, that's good. Now, for this project, at the beginning, we shouldn't have target force, but at this point, we should have target force, not for entire flip particles, but it's growing from the center. For doing that, I'm going to drop down a subsolver, merge it with this graph, and let me enable gravity. Okay, inside the subsolver, from this node, we have the flip particles. I'm going to drop down sphere, push it down, set a red color and green color to the particles. Then we can use attribute transfer sub to transfer red color from sphere to the points based on distance threshold. Okay. We need to set keyframe for distance threshold. For example, from frame 25, it's 0, and in frame 50, it's something like 4. Then we could set mask attribute for the red points to 1 and 0 for the green particles. So we can use the attribute wrangle, mask, and mask attribute is equal the red value of the points. But we just need to have the mask attribute. It's good to copy only the mask attribute to the original points. So I'm going to use the copy, attribute copy. First input to the original points, second input to the mask, and just copy the mask attribute, not CD. And it's good to have output node here. Let's check it. At the beginning, we shouldn't have any target force. Okay, I think it's working, but the problem is these points are so far away from target object and it cannot attract those particles. To check this, maybe we could push down target object a little bit. No. Okay, I find the problem. Actually, the setup is correct and it's working, but when I wanted to test it, I shouldn't push the target object down from object level because inside the target force, we are reading the target VDB and it's not using the transformation from the object network. Instead of doing that, I'm going to push it down inside the geometry network by using the transform sub. And now if you play, okay, as you see, some of the points are attracting toward the target object, so it's working. Okay, let me turn it back to the normal situation. We shouldn't have the transform sub here. And the points are spreading too much. I would like to use pop drag node here to decrease their velocity a little bit, so they shouldn't spread too much. Okay, but right now the problem we have is the points are not attracting toward the target force once they are so far away from target force. To fix this problem, we can use another force to push the points toward the target object even if they are so far away. And after that, because those points are close to the target force can manipulate the velocity of those particles. For doing that, we need to use another pop-up. Let's call it distance object force. Here we have the target mesh, not target VDB. We need to find the nearest points from the target mesh based on each individual particle. So for example, for this one, let's say we have this point, this point, this point, and this. And then produce a vector toward that nearest point per each particles. And use this vector to control the velocity of the particles. So let's do that. Before to start, we need to have the polygon version of the target object. So I'm going to use another null here. Let's call it target mesh. Inside the Autodop network, in the input, we need to read target mesh, not target VDB. And by using XYZ distance node, we could find the nearest point as well as the distance between each particles and target object. To read the position of these points, you need to use the primitive attribute node, prim to prim, prim UV to UV, and connect file to second input, read position attribute. Let's see if it's working. To produce this vector, we need to subtract this position by the actual position of the particle. So subtract node. First input is pause and second input is P here. And don't forget to add it with incoming velocity again. Okay. Let me disable it just to see if this node is working. Okay, it's working. But once the particles are close to the target mesh, we need to disable the distance object force, because after that the target force is attracting that particle toward the target VDB. So for doing that, we can use the distance attribute. If we have the distance between each particle to the nearest point, we can say if the particle is closer than certain distance, we want to decrease the amount of this velocity. So for doing that, we can use the distance attribute here, but it's good to use the fit range if we need to remap the distance. For example, in this case, let's say 0 and 1 as a source mean and max. It means that if the distance of the particle is less than 0.5, the output is 0. And if we multiply it by vector, which we have here, okay, it means that we shouldn't have any distance force. But if the distance is more than 0.5, the output is something more than 0, between 0 and 1. So we are using the distance object force only when the particle is far away from the target object. Okay, but we need to do same thing as what we did here. I mean, using the mask attribute, because we just need to use the distance object once the mask attribute is 1. So I'm going to use another bind node here and multiply it by the velocity vector which we build here. Okay, it's working very well. But also you can see the points are tending to be toward the bottom of the target mesh. That's because the gravity force are affecting on those points as well. So what I'm going to do is disabling the gravity force and using a pop force at this point. We can call it gravity. And here I'm going to use -9.8, and we need to have gravity force only when the mask attribute is 0. So if the mask attribute is 0, we just need to use the gravity force. If the mask attribute is 1, we don't need to use gravity force because we need to use the target force and distance object force. So here we can say force multiply equal by mask attribute. And that's why I disabled this node here, because we cannot use this Vex expression per each particle with the regular gravity force here. Okay, it's not working. Let's check it. Okay, it's working only when the mask attribute is 1, but I said it should work when the mask attribute is 0, so we need to invert the mask attribute. You can do this by using 1 minus mask attribute. So it's the opposite way of the mask here. Once the mask is 1, we are using the both distance object force and target force. Once the mask attribute is 0, we are using the gravity force. So far so good, it's working very well. And I think the distance object force is a little bit too intense, so we could decrease it by multiply constant node here, set it to 0.35, for example. Okay, it's better. Now I want to add more interesting motion, maybe swirly motion to the particles when they are rising up from the floor. For example, here, as you see at the beginning, they are spinning around the target object, and we have much more interesting motion on the particles. For doing that, we can use the curve force for the particles. Let's create another geometry network. Let's call it line force or curve force. Drop down line sub. Set length to maybe 10. Where is the ground plane? Here. Let's push it down a little bit. Okay, that's good. Inside Autodop network, we can use pop curve force. Point it to the line which we have here. We don't need to use the follow scale, suction scale. We just need to use orbit scale. Set it to 10, for example. But same as a target force and distance object force, this node should just apply curve force only when the mask attribute is 1. So we can use the same expression here as well. Turn this option on. The name of this parameter is scale orbit. So scale orbit multiply equal by mask attribute. And also you need to do same thing for air resistance here as well. So the name is air resist multiply equal by mask. Oh, there is a mistake. Oh, I forgot R here. Okay, maybe 10 is too much. Let's decrease it by maybe 5. Okay, that's better. But after, for example, frame 56, we don't need to use the pop curve force. So here I'm going to write down simple expression for activation parameter $f equal, sorry, less than 56, for example. Okay. We can also use pop wind here to add some turbulence force to the particles. Same as the pop curve voice, we only need to use it only when the mask is 1. As an amplitude, I'm going to use 3 or maybe 5 and multiply amp by mask. We have air resistance here as well. So again, air resist multiplied equal by mask. Okay, it's working, but same as pop curve force, we only need to use pop wind when the frame number is less than 56. Okay, working very well. Let me take a flip book. Here is the flip book, but be careful when working with fluid compressed node. As you see, we don't have any particles inside the object, it's just in the outside. That's because we are using particle and compressed fluid surface. Just set it to particles and also turn off this option here. Now we have particles from in the inside as well. Now it's time to work on the last part of our setup, which is about this frame. The water is pouring down once the logo is built completely. So for doing that, I'm going to create another geometry network and call it pouring Effector, for example. And we can use simple sphere again and transform node. Set keyframe, for example, after frame 120, it should go toward the target object until frame 145, something like that, and stay there for example around 50 frame, and then we need to scale it up to cover entire flip object. So set uniform scale to, for example, something around 7. So the pouring is starting from this point, and after certain frame, all of the liquid are pouring down. And the name is out Effector. But don't forget to use point from volume at this stage, because I'm working with uniform scale as well. Later on inside subsolver, I want to use another attribute transfer sub. Let me show you here. Suppose we have a grid, color attribute, green for grid and red for the points, attribute transfer here. Okay. If you are not using the point from volume at this stage, you will have something like this, because we don't have anything inside the sphere, but we need to use point from volume to have some points inside sphere, so it's working correctly when you are changing the scale here. Go inside Autodub network, inside the subsolver. We need to read that sphere here. Powering Effector. Okay, again, I'm going to use the color. It's red and green for the particles. Attribute transfer. Transfer color attribute from sphere points to the particles. Decrease distance threshold to something like 0.25. Okay, let's see what we have by now. Okay, here is the result. We definitely need to have more points inside the powering effector. Now, how we can use this red color inside subsolver to control the blending or morphing operation? It's not too hard. Again, we need to control mask attribute based on red color. Once the points are red, the mask value is 0, and because of that, all of these nodes are not working anymore, and we are not going to have any morph. But there is an important note here. Let me show you. Suppose here is our logo, and we have effector object here. So the effector is turning the color of the particles to red, so something like that. And because the color is red, the mask is 0, and the particles are pouring down like this. But because we are using attribute transfer here, and we have some kind of the distance threshold, some particles are turning back to, for example, green or whatever color after certain distance. So the mask attribute for these points are not 0 anymore, it's 1. And again, these points are going again toward the target object, because the target force and distance object force are working for those points. What we need to do is keep the mask attribute to 0 even if the particles are going beyond of the distance threshold. So how we can do that in the subsolver? It's so simple. I'm going to drop down wrangle. I would like to use another attribute, effector equal @cd.r. If the mask attribute for red points should be 0, right? So let's say if effector is greater than 0, mask attribute is 0. So it should work, but to fix this problem, let's say here is the distance threshold of attribute transfer. The particles before distance threshold are red and after distance threshold are green. And this is where the mask attribute should be same, which is 0. So for doing that, to fix this problem, I just need to say effector plus equal @cd.r. And don't forget to use clamp function here because we are using plus equal here. The number of effector is increasing more than 1. So I'm going to use clamp function to make sure it is something between 0 and 1. Clamp it between 0 and 1. Now, because we are using plus equal, the effector attribute for these points are 1. And after distance threshold, the red color is 0. But here, the previous value of effector was 1. 1 plus equals 0 means 1. So it's staying 1 forever. And because the value is more than 0, the mask attribute is staying at 0 number. Let's see if it's working. Okay, it's working as what we expected. Now let's go to the last part, which is about lighting, shading, and rendering. For rendering, we need to save the simulation to the disk, so I did that with this step. And here is the simulation. But I increased the number of particles a little more. If you go to Autodub Network, I set the particle separation to 0.023. Also, to make this tutorial shorter, I've added some new notes here for you. If you open this project, custom force underscore render, you will have these notes. Just let me explain what I did exactly. Here is the flip mesh. As you see, nothing so fancy, but at this stage we need to do some tweaks here when converting the particles to the mesh. To have less flickers on the flip mesh, it's good to set the method to spherical. And also in the filtering, I'm going to turn on this option and maybe smooth it out a little bit. And here we have environment object. It's so simple. It's just a simple curve, something like that, and then using the skin to add a surface between these two curves. Convert it to polygon, push it down a little bit because I don't want to have any intersection between the environment floor and the flip mesh. And here we have camera. We have two light sources. The first one is just regular environment light, and it's pointing to HDRI texture which you have in your project directory inside the pics. HDRI2, it was a free HDRI which I've downloaded from internet. And we have spotlight with this intensity and exposure from this direction. And yeah, that's pretty much it. Now let's apply two different shader for flip mesh and environment. For this project I'm going to use Mantra, but of course you can use Karma, same as the previous tutorial. I'm going to drop down Mantra node, and the camera is correct. In the Objects tab, we need to render flip mesh and environment. Okay, now let's create a shader for the environment. I'm going to use Principal Shader. And we could call it environment. In the object, environment, render, assign it to the environment object. Okay, for base color, I'm going to change it a little bit. No, I think that's fine. But for a specular, we don't want to have any reflectivity. Okay. For these two materials are made by Philip Floyd from Object Shelf Tools. We don't need them, so I'm going to remove them. Another Principal Shader, call it Liquid, for example, and assign it to Flip Mesh. You can just drag it into render view. Okay, it should be the transparent shader, so I'm going to set transparency to 1. Now it's transparent, and again, like previous tutorial, this black shadow could be fixed by turning on fake caustics. In the surface, the specular, I would like to set index of refraction to 1.33, which is mostly useful for water, and to have completely sharp specular, I'm going to set roughness to very, very small number, something like that. We could make environment object a little darker. Let's try 0.9 for example. And also we need to turn on motion blur, but don't forget to go to the flip mesh object in the render tab, sampling. Don't forget to set this parameter to velocity blur, because by default it's set to no velocity blur. For flip simulation, we need to use velocity attribute for motion blur. If you check attributes here, we have V. So for motion blur in the Mantra, in the image rendering, and here we have allow motion blur. Just turn this option on, and now we should have motion blur. And for final render, you need to increase pixel samples. Usually I'm using 6 and 6. The render is almost done, and yes, we have motion blur, and the result is pretty much same as what I have here. Of course, here I've used Nuke software for compositing to make it more beautiful. Mostly I did some tweaks on the specular to add these highlights area. I would suggest you to go to the image, extra image plane, and turn on maybe shading depths, which is useful for depths of field in the nuke, and direct and indirect lighting. By turning on these options, we will have some AOVs, for example, PZ, direct diffuse, direct reflect and refract, indirect reflect and refract, and something like that. So inside the nuke, you can do something, for example, specifically on the specular, same as here. Maybe motion blur is too much. Here we can use wrangle to scale down velocity attribute, for example, by half. So times equals 0.5. Okay, once you were happy about the result, you can just render it to the disk. For example, I'm going to create directory here. We can call it, oh, we have render. Okay, for example, water morph. Water dot $sign f4 dot xr. The frame range is between 1 and 240, for example, and then press render to disk. Okay, that's pretty much it. Thanks for watching this tutorial, and see you in the next one.